Okay, so just to recap what we did about a week and a half ago, almost feels like 2 weeks ago. We did this. We talked about log base b of x equals y is the same exact thing as saying b to the y equals x. It's the same exact thing. So it's really a mechanism, and that's really the key thing I want to get through to you guys today is how this shifting of variables works out. So if you just think about it, it's like this y jumps over from right to left, the b shifts up, and x jumps over. So 3 letters are changing places. That's why it's a little confusing. But once you get the hang of it, you do enough, this is fine, right? So you have x and y, you switch. Actually, probably easier to do it this way. X and y switch places, the log goes away, and that's it. So it's gonna be like this. These guys switch, so you have this, and it's not correct by the way. It's not, it's a total. Don't want to set, but then what happens? That goes. So you see what I just did? Switch x and y. Switch x and y, and then you erase. Does that make sense? So for example, what if I have exactly, yes. What if I have log base 2/8 equals 3? So what's going to happen? The 3 and 8 switch, and the log drops off. Is that a true statement? Is 2 to 3 power equal to 8?
Yeah.
Yeah, 2 times 2 times 2 is 8. So, for example, if I look at this one here, part A, 81, or you could do this. You could switch 81 and 4. 3 and 4 equals 81. Okay, what about part B? What would that be like? 14 and 0 equals 1. Jim, you have a question? Okay. So it's simply a movement of numbers and letters, if you want to think of it like that. Okay. All right, so how about this? Let me set you guys up with these next 4. You guys try them really quickly.
I just go equal out.
Yeah, or any letter. It doesn't really matter. It's up to you. So here's how it works, guys. The 64 and y trade places, and the log drops off. So 4 to the y equals 64. What would y equal here, guys? 3. There you go. Try the other 3. Tell me what you guys get. Try the other 3. And by the way, 0.2 is the same thing as 1/5, just so you know. Okay, let's try it out. Good, you got it. I know you guys are a little rusty. Hold on, let me be consistent here.
That's not real. You do this.
Okay, so far we're okay. Can we put the pause away? All right, so see here, 0.2 jumps over, becomes 0.2 knows 1/5, so it jumps over, and you get 5 to the y equals that. Here, the 125 jumps over, you have 1/5 to the y equals 125. The 6 jumps over, 36 to the y equals 6. So if you're extremely consistent, these should not be that bad. Now, what do you think y would be for part B, this example? What would y be?
-1.
Good. Yep. Y would equal -1. Be careful of this one. 125 is a power of 5. 5 to what power is 125? Good. But then that's also what 1/5 is 5 to what power? Good. So you have 5 to -1 raised to the y equals 5 cubed. What would y have to be to make this work? Good. Excellent. Y would be -3. And then 36 to the power of 6, right? 6 to what power gets you 36? Squared. Good. So it's like 6 squared to the y equals 6. What would y have to be to make this work out? 1/2. Good. Excellent. You guys are totally nailing this now. Good. I think the second time helps. So that's a log. That's a log is like an exponential function. Just things are kind of a little switched. That's really what's happening. So again, y is -1. I'm just doing this on the screen just for those who have to watch this at home. Y is -3, and y is 1/2. So, okay, let's keep on moving. There are two other types of logs we have to talk about. A common log is a log with base 10. So it just looks like this. So it kind of look like that. So if you think about it, you don't see a base, right? You don't see a base, assume it's F1. So when you have a common log, base is not shown. Let me type this up. When base is not shown, I'm giving you an example. And sorry, sorry I didn't write this on the screen. This is an example. So you don't see a base, right? So what do you assume the base is again? It's 10. So now the question is 10 to what power equals 100? 2. You did 10 times 10, Haley. And that's okay. That happens. But remember, you have to multiply 10 a certain number of times to get to 100, which is twice, right? Yeah. So, okay, no worries. It's all good. It's okay to make mistakes. So you get 2. So, example 3, I'm still going to skip for now. I'm going to come back to it. Probably get to 7.6 because example 3 is a little much, I think, for now. So I'm going to cross off example 3 for now. We'll come back. So cross off in your worksheet as well. But we will come back to and revisit it later. Natural log. Natural log looks like this. It's a log with base of E. And remember what E was?
2.71.
Euler's number. Yep. Euler's number. Let me write that more nicely. Okay, good. So anyway, let me give you an example here. What if you have ln and you write it as ln? You write as ln. So what if you have natural log of, say, e squared? Okay, here's how you want to think of it. So I'm going to set this equal to a box on the other side. Okay, so it's the same thing as saying log, yikes, log of base e of e squared equals, I'll do a green box.
Would it just be?
So what do you guys think this would be? What do you guys think what should I put in the box to make this work? No, not e. Close, getting warmer. So the e squared, so remember we said we swap? We do a swap. So let me get the pink out again. E box equals what goes in the box? 2. The answer is 2. Because think about it. You have to raise this to the second power to make it equal this, right? Or this e squared swaps with the box, right? Then you drop off the log, e squared is e squared. So whenever you see ln, assume the base is e, and you do the same exact thing we've done for the previous problems, where you do this little switch, right? You switch this and this. But it comes base e to the box equals all this right here. Just like we did earlier, right? Like for example, if I have like log base 5 of 25, What do? I do 5 raised to the box equals 25. Of course, that's 2, right? It's the same exact thing. What if I replace the 5 here with an e and replace the 25 with an e squared? Same exact thing, right? Replace the 5 here with an e, replace the 25 with the e squared, you get the same exact thing. The box would be a 2. So you'll have a chance to practice that on this stuff today. All right, let's keep on moving. Let's do inverse. And I'm going to hold off on graphing today. I'm going to hold off on graphing because I think I still need a little more time to simmer on the mechanism of log. So I'm going to hold off on graph because I think I lost you guys. Of course, it's Spirit Week, and I think you guys really amped up after the whole activity, whatever activity it was that day. So I'm going to hold off on the graphing part, save that for another day. Let's talk about inverse, and then I'll have you guys work on the worksheet, which will be part of your homework. Because you have 7 classes today, instead of doing classwork today, I'm gonna have you guys do the homework instead. So that way you don't really have much homework tonight, because this is why we don't do 7 classes today, by the way, because I have like 7 homework assignments every night is kind of crazy. So after I finish number 4, you guys can get a head start on the homework and hopefully get done in class today. I can walk around and help you guys out. Then we should feel more prepared for tomorrow. So, all right, really quickly, how do I find an inverse? Yep, you flip X and Y. Yes, thank you, Hugo. That's perfect. Flip X and Y, then solve for Y. Ah, that's hard to read. Then solve for Y. Okay, so you switch X and Y. Same page we've been on? You know? Okay, you're good? All right, thanks. All right, so you have this. Now, this is a little tricky. Because remember we said log base bx equals y is the same exact thing as y, or as b to the y. Let me switch colors. This is not good. Here we go. The same exact thing as b to the y equals x. So here I have 6 to the y equals x, right? So this is like your b, right? So you can write as log base 6 of x equals y. There's not really much work to show, to be honest with you. It's really more understanding the switching of all the letters and numbers. So the first step's easy. You guys know switch x, you know, inverse. But then how do you get this by itself? This is why we have logs in the first place. How do I get this by itself and rise a log equation? So what's going to happen is that this is your base, right? So it becomes the base of the log. If this is the base of the exponent, it's the base of the log as well. And then the x and y switch. Because if you think about it, how would I go from here to here? When I do x and y switch and 6 to the y equals x, right? The x and y switch, 6 to the y equals x. It gets you back to the same thing we had purple over here. So again, to isolate the variable, use log. To isolate the variable, use log. Since that's your base, that's gonna be your base right here. That all comes from this again, right? What was in b's place? A 6. Excuse me, a 6. So you got the 6 here. And there you go. That's it. That's all you do. Let's try this again for part B. I'll leave up part A in case you're still simmering on it. Let's take a look at part B. And after we can start the work. Switch x and y. Easy peasy, right? Now, what is ln, guys? Log of what base? E. So I'm going to do a second step. Now, what do I do, guys? There's only one more step, but it's the most crucial step. I'm gonna put a star next to it. It's the most crucial step. So how would I write this? How would I get y by itself? So the y plus 3 and x switch, right? The y plus 3 and x switch, and you drop the log. So it becomes, what's on the right side then? Good, excellent. E to the power of x. And I lied, there's still another step to subtract the 3. That would be the inverse of the function you see up above. Those are inverses of each other. There is a graphical way of seeing this, but I think for today, I don't want to overwhelm you with too much information because you have 7 classes. Trying to be mindful about that. I think you guys just need to practice moving things around. So what I've done is I prepared this worksheet. It's really good. I will put in Schoology as well in case you want to do electronically. It's 2 pages, but don't worry. The second page is the answers. And it's color. It's a color copy. I didn't intend for it to be color, but it's okay. So the ones in red are the answers. So you can check your work. And it's a total of 34 problems. But some of these problems take like 5 seconds. So I think you guys can get it done by 7 o'clock. So let's get done here. And this will count as your homework. So when you're done, just take a picture and upload it to Schoology. This will count as your homework assignment. Here we go. And ask questions. I'm gonna walk around and get it up.
Go ahead with the time.
Okay.
Well, can you go? Are you good enough to play left? What is their playlist like?
Well, thank you guys.
So see you guys again tomorrow. Just
Yeah.
back to normal. Yeah, we used to have like 16 years ago, we had some more Monday things like this today. Yeah, also the top.
Let's go.
And he was, yeah.
Wait, exponential looks like this one, right?
I mean, if you don't finish this homework, that's just tomorrow. But I think I want to give you guys.
Okay, so I
I
don't
want
know.
to give you guys.
You make the equation an exponential.
But I think you guys can get done.
Log 6, so it's gonna be 36.
Wait, Mr.
Go ahead, go ahead.
It's like the final one of answers.
That's it. Yeah, and if you look at the answer key. It's like that.
Oh, okay.
Yep. Yeah, so you guys have the answers on the second page. See if you're doing it right. Okay, I'm gonna stop the recording.
6.